All right, so chapter 7. Big difference between chapter 7 and chapter 6 is chapter 7 now has an equal sign. That is pretty much it. We're going to solve quadratic equations in chapter 7. And we're going to do 4 sections. So I think between the next 3 days, we should have all these sections done. Now, good news. When you're taking the test, it's going to tell you to solve things a specific way. However, the test is not going to know if you solve those things in a specific way. So don't stress over that. Solve it the best way you like to solve it. So in chapter 7, we're sticking to what we call the quadratic equation, right? The general quadratic equation, which is ax squared plus bx plus c equals 0. Right, and so this is called the general quadratic equation. And some of you might or may not already know the quadratic formula. We will get to that. But we're going to learn basically 3 ways to solve this. So 7.1 is solve by factoring. 7.2, solve by complete the square. 7.3, solve by quadratic formula. And 7.4, graphing a quadratic. So there is the next 4 sections, right? So basically, we're just going to learn 3 different ways to solve it, and then how to graph it. Right? Everybody will have their preference. Most of you will prefer this method. Right? This is a quick method that we'll learn today. However, you can only solve it if it is actually factorable. Completing the square is the initial process that we've learned. And basically, if you complete the square of the quadratic equation, you will get the quadratic formula. So the completing the square is the process of solving this entire thing. So 7.2 is the proper process. 7.1 and 7.3 are cool tricks that someone came up with. Oh, excuse me. All right. Now, the big part of 7.1 is you must get this thing to equal 0. And I can get any equation in the world to equal 0 if I just move everything to one side. So move everything to one side. And if I move everything to one side, then there's nothing left on the other side, therefore it equals 0, right? So going into 7.1, so there's the kind of the overview for the next 2 weeks, followed by our test on chapter 6/7 on Pearson. And there's some of you who still do not have a Pearson set up. You might want to do that before the test day. If you don't have your Pearson set up by test day, then you won't be able to take the test. If you're having problems, please reach out to me. There's 24 in the class, 18 of you on Pearson. So there's 6 of you that still need to set up your accounts. So 7.1, how do we solve quadratics? So here are the steps I've come up with. Step 1. Move everything to one side. So the equation equals 0. That's the key. And then make sure you also combine like terms. Step 2, factor. And this is from chapter 6. So you have to understand the procedures from chapter 6 so that you can actually solve using this method. Step 3, set each factor to 0. Right? And the reason we can do this, right? So think about it. If I have, so here's a little example. Say I factored something, I get x plus 3, and then x minus 2, and that equals 0, right? Because it equals 0 because of step 1, right? Well, if I use the zero factor law that we learned way back at the beginning of the semester, I am multiplying these two polynomials together. So as long as one of them equals 0, well, 0 times anything is 0. So therefore, this equation will still work, right? So that is the whole reasoning why we set each factor to 0, because of the property we learned called the zero factor law way back at the beginning of the semester. All right, and then we go on to step 4. Solve each factor. So what was I just had? What was it? X plus 3, x minus 2 equals 0. So what I do is I take each one and I set them equal to 0. And then I just solve. So minus 3 minus a 3, x equals a negative 3. X, oops. Plus 2, x equals 2. And then lastly, step 5, check. You check your answer, you cannot get it wrong. So there's the 5 steps to solving by factoring, right? So come back here for a minute. So step 1, make sure it equals 0. Step 2, factor. The good news about using this method, if it doesn't factor, then you can't go on, and then you have to use one of the other methods. Step 3, set each factor to 0. Step 4, solve each factor by taking each factor, making a set of the 0 and solving it. And then finally, you can put your answer back in, and you should get back to the equation you started. Any questions on the steps?
So in chapter 7, we're getting 2 answers.
Yes, you can have anywhere from 1 to 3 answers.
Okay.
So let's do an example. So what if we have x squared plus 4x equals 21? So step 1, make this thing equal to 0. Well, to do that, I have to bring the 21 over, so therefore I subtract 21 from both sides, and I get x squared plus 4x minus 21 equals 0. Now, I will give you a minute or so, because this is review for chapter 6, to see if you can factor this real quick, and then I'm going to give me a drink of water, and I'll come back and I will start my factoring method. All right, so since a is 1 in this case, right, there's no number here, so I know that's a 1. All I really need to care about is this negative 21, right? So over here on my scrap paper, I do negative 21, and this is the sum product method or beam method. If you like the AC method, you can go through the whole steps, but I'm going to do my sum product method in mine here. See if we all get the same answer. So our factors of negative 21, that will give me 4. A positive 4 would be a positive 7, a negative 3, which gives me a positive 4. Right? 7 minus 3 is 4, and 7 times negative 3 is negative 21. And then I said this works really good when a is 1. Then all I have to do is put an x here and an x here for my x squared. And then put a minus 3 here and a plus 7 here, or vice versa. It doesn't matter which place you put them. Because negative 3 times 7 is negative 21. X times x is x squared. Negative 3x and a positive 7x give me my positive 4x. So my factor is complete. And this is equal to 0. So step 2 is done. So step 3, I take each one of these. X minus 3 equals 0. X plus 7 equals 0. Add 3. X equals 3. Subtract 7. X equals a negative 7. So there is my step 4. And then step 5, I can check. So if I check my first answer, I have 3 squared plus 4 times 3. So 3 squared is 9 plus 12 equals 21, which is where I started. So that's the right answer. And I do the same thing with the 7. Oh, sorry. What did I do wrong here? Oh, no, I'm okay. That's supposed to be negative 7 too. I know I made a mistake somewhere in my math, not my math, but my wording here. Take off the eraser. Negative 7. So now I do a negative 7 quantity squared plus 4 times a negative 7. So negative 7 squared is 49. 4 times a negative 7 is a negative 28. 49 minus 28 is 21. So that is also a correct answer. So I'll write it up here in the corner because I ran out of room. X equals, I'll put it in curly brackets, set notation, 3 comma negative 7. So that's probably how you'll see your answers on Pearson, in curly brackets with a 3 and a negative 7. So that, we just took this quadratic, x squared plus 4x equals 21. We solved it by doing factoring, and the two values that will work is 3 and negative 7. Any questions? All right. So this next one we're going to try is not actually a quadratic per se, but this methodology will still work just so you can see how it works with almost any problem that's factorable. So if I have 18x cubed plus all right, sorry about that. Just answering a comment. 18x cubed plus 2x equals 12x squared. So, again, doing the step process here. Step 1, get this thing equals 0. So I can do that by minusing a 12, not 21, minusing a 12x squared for both sides. So I get 18x cubed minus 12x squared plus 2x equals 0. So then step 2, factor. Remember, to factor, the very first thing we always should check for, which I didn't do in the last problem because I'm horrible at it, but we should do it, is there a greatest common factor, right? So in this case, I can see all of them have x's, so I can pull out an x. Right, so we're doing the GCF right now, remember from way back in chapter 6. They're also all even, and 2 is a prime number, so that's my smallest even number, so I can pull out a 2. So there's my greatest common factor, which leaves me 9x squared minus 6x plus 1 equals 0. That's an ugly 6. Let me clean him up a little bit. So now I have a greatest common factor, and I have a trinomial, sorry. And now my a is not 1. So you can still do my methodology, but it's a little trickier using the sum product when a is not 1. So again, I'll give you a minute or so here and let you see if you can factor it, because that part is a review from chapter 6 and a good practice for the test, because a good portion of the test is factoring. So you definitely want to make sure you know how to factor. All right, so let's see here. So again, depending on what method you used, I noticed a little pattern here. And part of it I noticed it because I came up with the problem, but that is a perfect square, and that is a perfect square. So if I take the square root of 9x squared, I get 3x. If I take the square root of 1, I get a 1. 3 times 1 is 3, and if I multiply it by 2, I get a 6. So this is a perfect square trinomial. So since I know it's a perfect square trinomial, I put my 2 square root answers in parentheses. I keep the sign of the middle term, and I just rewrite it again. Now, if you did the AC method, hopefully this all still worked out with you, or any other method. But again, these are kind of refreshers of all the special cases. You don't have to know them, because AC method always works, or whatever method you're using, as long as you don't do it wrong. But that's where we're at. So there's step 3. I have factored it. Now I take each factor and I set it equal to 0. So notice this time I have my greatest common factor. I also have to set him to 0. My 2 factors are the exact same thing, so I don't have to solve them twice. So I'm only going to solve one of them, because if they're the exact same thing, so I'm going to get the same answer. So now when I go to solve it, my greatest common factor, to get my x by itself, I divide by 2. Well, 0 divided by anything is still 0. So in this first one, x equals 0. If I have a greatest common factor, it is always going to be 0. Then I add 1. So therefore, I'm running out of room. So I get 3x equals 1. Divide by 3. Divide by 3. X equals 1/3. And again, I highly encourage you to go through and check your answers. 0 is easy to check. If I put 0 in for x's, I get 0 times 18 is 0, 2 times 0 is 0, and 12 times 0 is 0, so 0 equals 0, so therefore 0 works. So if you have the variables do everything, then one of the answers is 0. All right. Any questions on this one? So this one shouldn't be too bad for you, unless you're having problems in chapter 6, then this probably is not enjoyable for you at all. But all we've done for 7.1, the only new thing we've done is taken our expressions, which we were doing in chapter 6, and set them equal to 0. And by setting them equal to 0, we can now actually solve them by doing, oops, that's a different, there we go. By doing the 5 steps. We're going to set it equal to 0, factor based on chapter 6, set each factor equal to 0, solve each factor, and then check. Any questions on 7.1? Not going to spend a lot of time on 7.1 unless people have questions, because it's just basically chapter 6 again. But a good review from what we've been learning for the last 2 weeks. All right, completing the square, 7.2. This one has got a lot of procedures, and most don't really care for this one. I always have 1 or 2 students who like it, though, and they do use it. Complete the square. So one thing before we get into complete the square, let's kind of review some rules of radicals, right? So say x squared equals k, and I want to solve for x, then x equals plus or minus the square root of k. Now what I mean by that is, if I have x squared is equal to 25, then I take the square root of 25, which equals 5. So x equals 5. However, the whole reason we have this plus minus thing now is, what if I have negative 5, right? Well, if I put negative 5 back in here, negative 5 squared, well, negative 5 times negative 5 is 25, and 25 equals 25. So there is 2 answers. So we've added this little plus or minus thing outside the square root. Because when I take the square root of a number, if I substitute it back in and I'm solving it, it can have more than one answer. So that's where it gets a little tricky, because most of us, like if I ask you what's the square root of 9, everybody's gonna tell me it's 3, right? Because that's just the square root of 9. But when I put it into algebra and I ask you if x squared equals 9, I'm asking you, what can x be, right? Well, x can be 3, but it also can be negative 3. So don't get these 2 things confused. The square root of 9 is 3, right? But when I put a variable to an equation now, and I ask what x can be 2 different answers, all right? Now, steps for solving quadratic equations by doing complete the square. And I really wish we were in the classroom for this, so I could do this, write this all out, plus have an example by it, because these are where it gets kind of confusing. But we will go through it, right? So first thing I like to do is, first step, move all well, we'll use proper terms here, constants, to one side. And remember the quadratic equation, right? The quadratic equation is ax squared plus bx plus c equals 0. Well, c oops, I didn't mean to cross that out, I meant to underline it. Constants. C is the constant. So basically what step 1 is telling me to do here, it is saying move C to the other side. So ax squared plus bx equals negative c, because I had to subtract c to get it to the other side. Now, don't think the answer is always going to be negative, right? You're just moving the number over that's there without a x attached to it. That's the only thing you're doing in step 1. Get the number that doesn't have an x attached to it and move it to the other side. So it's no longer equal to 0. Step 2, divide by a. Right? All right. And divide by a means to get x squared by itself. That's what basically this step is telling you to do in non-math terms. So if I divide by a, right, so I have ax squared plus bx equals a negative c. Then I divide him by a, and him by a. So x squared plus b over ax equals a negative c. All right, so there's the first steps. And I know it looks ugly with just letters. I promise we'll get here in a second. But I wanted to at least show an example what it means to where a is. And my a's look like 9, so let me fix those. Those are supposed to be a's.
Why did you drop the a on the end, like negative c divided by a?
Oh, I didn't mean to. Thank you for pointing out my mistake. Nope, that's a mistake. Thank you. Yes, there should be an a there as well. So there is the first 2 steps, and they're the tricky parts of the steps, right? And so this is the thing. Now, the third step is where I like to say go to scrap paper. This third step is what we call completing the square, right? So I like to do step 3 on scrap paper. I can't write today. On scrap paper, because this is where people kind of start to do step 3 and they try to do it to the whole equation and it kind of messes them up. So you take your middle term, right, which currently is the b over a. You pull that out, not with the x. So you just take out the number in front of x. So all we care about, right, and for this step is the number in front of x. X. So on my scrap paper, what I do first is step 1 of my scrap paper is I take b over a, and I divide it by 2. Or if you prefer, b over a and multiply by 1/2. So if I'm dealing with a fraction, I multiply by 1/2. If my b over a is actually an integer, then I just divide it by 2. They're both basically the same thing. It's just whichever math you prefer, right? And then what you do, step 2, square your answer. And then step 3, add your answer to both sides of the quadratic. That you're trying to solve, right? So this is my little scrap paper piece. People try to do this piece while it's still in the equation and they get confused. Don't do it while it's still in the equation. Do it on scrap paper, and then you just take your answer and add to. So basically what you end up getting is b over a, b over 2a. I'll clean this up. Give myself room. You basically will get your b over 2a quantity squared. And it will give you a number. So you're not going to have this ugly mess that we have right now. You will have some number, right? This will give you a number because there's no variables in this. And then you just take that number and add it to both sides of the equation, right? And then step 4, and I promise this will make a little more sense here in a minute. You want to factor the left side. Step 5, take square root of both sides. Step 6, solve the square root. And step 7, solve for x. Well, I'll put solve for the variable in case it's not an x. And then again, if you want to, because we have an answer, you can check. Lots of steps. I think the book breaks it down into 6 steps. I went a little bit more because I broke them down a little bit easier to kind of see. So let's do a couple problems here. If I have 9x squared plus 6x minus 1 equals 0. So step 1, I have to move my c over, which is my -1. So I need to bring him over there by adding 1 to both sides. So I get 9x squared plus 6x equals a positive 1. That's why I said the answer is not always going to be negative. It's just the minus meant to move it. Now, if it is already set up this way, then obviously you can skip step 1. All right, so there's step 1. Step 2 was divide by a, which in this case is the 9. So I'm going to divide him by 9, him by 9, and him by 9. Now I get x squared plus, I'm not going to simplify yet, so you can kind of see where these are all coming from. But we should simplify the x, 6 over 9. And that's what we get. Oops, not plus, equals 1 over 9. So the whole point of this steps 1 and 2 is to get x squared by itself, right? Get nothing out here but that not imaginary, the invisible 1. And then get all of our numbers on one side. So you're getting all your variables on one side, your coefficient to the other, and you want a 1 in front of x squared. That's the point of steps 1 and 2. So if those 2 steps are already done for you, which they may on some problems, then don't stress over those 2 steps. Those 2 steps are kind of as necessary. Now we go to our scrap paper. So here's my little scrap paper, right? So I take what's in front of the x, which is 6 over 9. And I multiply it by 1/2 or divide by 2, which since I'm dealing with fractions, I want to multiply by 1/2. And I get 6 over 18, which reduces down to 1/3. All right. Then I take 1/3 and I square it, which gives me 1/9. So now I take my 1/9 and I add it back into my problem. So here is step 3. I get x squared plus 6 over 9 x plus 1/9 equals 1/9. I'm going to do it in a different color, plus 1/9. Right? So these 2 things being 1/9, that's just coincidence. All right, that does not always happen. It just happened for this problem. So please don't think those numbers are always going to be the same. It just happened for this problem. All right. So if I simplify my problem down here, I get x squared plus, I'm going to reduce this thing now. So 6 over 9 becomes 2/3 x. So I divided the 6 by 3 and the 9 by 3, plus 1/9 equals 1/9 plus 1/9 equals 2/9. Right? So now, I'll give you a second to write this down if you need to, because I'm about to go to a new page. All right. So I got x squared plus 2/3 x plus 1/9 equals 2/9. Now, I have to factor this other side. But the whole point of this is called completing the square. This became a perfect square trinomial. So I take the square root of this, I take the square root of that guy, and I get x, and I get a 1/3. My middle term's a plus, so it is a plus 1/3. And if I write it twice, is the same as putting a squared here. Now, what I want you to look at, and hopefully you are taking notes, back on our scrap paper, step 1, I got the answer of 1/3, right? Notice, is the same value that came out right there. That will always happen. All right, that's the whole point of this. You're taking a problem that is not a perfect square trinomial, and you are making it a perfect square. Hence why this is called completing the square. Again, hence, us mathematicians don't come up with cool names. We just use the name of what we're doing. And we are completing the square here. So therefore, I made a perfect square problem. So, and this still does equal 2/9. Now, to get rid of this square root for what step 4 is said to do, I think it was step 4. I'll keep my numbers matched up. What did I say? No, step 4 is factor. Step 5 is take the square root. So let me go back here. It should be a step 5. All right, so step 4 was the factoring. So I guess I could left that there. Step 4 was how I did all of this. Step 5, I'll do in blue so you can see the different colors, is to take the square root of both sides. Well, when I take the square root of the left side, this square root basically cancels him out, and I get x plus 1/3. And then to take the square root of 2/9, I'm just going to leave it as that for a minute, but remember how we started at the beginning of this lesson, I put a plus minus there. Now I solve for x, which just means I minus 1/3 from both sides. And I get the answer x equals a negative 1/3 plus or minus the square root of 2/9. And therefore, I think this is step 6 and this is step 7. Now I can simplify this down, right? So x equals a negative 1. X equals a negative 1/3. I don't need that equal sign there. I can't take the square root of 2, but I can take the square root of 1/9, which is just 1/3. So this becomes plus or minus 1/3 square root of 2. And then on the test and the homework, the radicals are always going to be simplified, right? So if you get an answer that's close to one of the answers, just make sure you can simplify it. And basically all you can do is take out the piece. If you're having problems, please let me know. It's just strange how we teach this. We haven't really learned how to evaluate things that are not perfect square roots yet. We learn that after this section, but we have to do it to do this section. So I haven't quite figured a way to teach it. I think maybe next year I'm going to switch my chapters around so that way we can actually do this piece, but I got to look into it more. But anyway, if you have problems on this on test day, whether your answer's not coming out simplified the right way, just kind of message me. All right, how do we do? Looking for questions. Lots of procedures to this one. We're going to do another one. Now, if you ever solve it and the radical's not there, which this one was supposed to work out that way, but I didn't write the equation down properly, so that's my fault. It just means it was factorable. So the completing the square always works, while factoring only works things are factorable. So you can do completing the square on something that is factorable. That's why I said when you go to do the test, Pearson's going to give you, say, solve by doing this method. Well, it doesn't know which way method you solve by. So let's do another one. What if we had, and this one I'm going to simplify a little bit before, because I think everybody will be all right with steps 1 and 2. So we're going to just jump to step 3. Yes, you can solve by any method you prefer. Pearson doesn't know which method you use. So here's our new equation. X squared minus 6x equals -4. So you can see step 1 is already done. The -4 is on the other side. Check. Step 2 is already done because the value in front of x squared is 1. Check. So steps 1 and 2 are already done in this case, because I think enough practice, those steps are not too bad. It's the steps 3 and on. So now we go to step 3 on our scrap paper. There's our scrap paper over here. And I always write that because it helps you remember. Plus students make a joke of it. So there's my little scrap paper. I take my value of b, which is -6 in this case. And then I can multiply 1/2 or divide by 2, which gives me a 3. And I didn't make my scrap paper big enough, so let's make my scrap paper a little bit bigger. So I divide by 2, and then I square it. So 3 squared is equal to 9. Right, so my scrap paper is done. So now I rewrite the problem. X squared minus 6x plus 9 equals -4. And again, plus 9. And notice this time we didn't get the same answer on both sides. So I said that was only because of that problem. So remember, the whole point of this is to make this a perfect square. So can you do the AC method to factor it? Yes. Can you do the sum product method to factor it? Yes. Should I use the perfect square trinomial formula? Yes. So I take the square root of this. I take the square root of this. I get x. I keep the middle sign, and that becomes a 3. Put it as squared. And then -4 plus 9 is a +5. And again, the value that's here is the same value that's here. That will always happen. Right? I recommend you check your work to make sure you're not doing anything wrong instead of just automatically writing it and skipping step 3. But because you still need to square it to make sure you get the right side correct. So I wouldn't skip the step, but it's a way to check your work or check your progress. All right, so now we've got that done. I can take the square root of both sides, which gives me, kind of write my steps down here in a minute, sorry. X minus 3 equals plus or minus the square root of 5. So this was step 4, step 5, and now we're on to step 6. And then on the scrap, did you mean to lose the negative on the -3? I did not. So that is supposed to be -3. Thank you. And the -3 quantity squared is 9. I did not mean to lose the negative number. That's why it's a common mistake for my students, because I do it as well. So then I add 3 to both sides. And x equals 3 plus or minus the square root of 5. And I can't do anything without that. And again, Pearson's not going to put it in decimal form. This will be the answer that you'll see on Pearson. So if you can't simplify your radical, then don't simplify it. And I know I can't because 5's a prime number. So therefore, there's nothing that can go into 5 that's the same since it's a prime. So there is completing the square. So we have a little bit of time here because we've been going, and I'm not going into 7.3. I'm not trying to cover all the chapter 7 in one day. So let's do this. Let me bring up my.
This is kind of confusing to me.
Yeah, completing the square is a tough process. So I would recommend that you write the step down and go through the steps. So what I want to, go ahead, man.
You be able to get how to do it this way?
Nope, Pearson won't know which way you do it.
Okay.
Some people will like it though. So if I have, what I'm going to do is I'm going to give you all a few minutes to solve this one, and then I will work through it my way, and then I'll answer any questions. So there's a little problem to end class today. 6x squared plus x equals 12. You may solve that by any method that you like. I will give you a minute, and I'll come back and I will continue to work this problem as well. 12. Divide by 6. X squared plus 1 over 6x equals 2. Scrap paper. 1/6 times 1/2 is equal to 1/12. 1/12 quantity squared is equal to 1 over 144. X squared plus 1 over 6x plus 1 over 144 equals 2 plus 1 over 144. Now I take the square root of both sides to get x, parentheses, x plus the square root of that is 1/12 squared equals 2 plus 144. Yes, I'll do the factoring method afterwards. Equals 289 over 144. Take the square roots, and I get x plus 1/12 equals the square root of 289 over 144. If I type that in my calculator, that better come up to a good answer now.
Where'd you get the 289?
It's equals 17 over 12. One sec, I'll answer that. 17 over 12. Right here. 2 plus 144. 1 divided by 144 equals 289 over 144. I used a calculator.
Oh, okay.
But if you want to find common denominator, remember he has a 1 on him. So that means I have to multiply 2 times 144, which is 288 plus 1 is 289. So I'm going to run out of room. I have finally x plus 1/12 equals plus or minus. I'm still running out of room. I need a bigger whiteboard or write smaller, one of the two. X plus 1/12 equals, and when I said the square root of 289 over 144 was again 17 over 12, plus or minus 17 over 12. So subtract 1/12 from both sides, and x equals -3/2 and 4/3. Now, someone asked me to do the factoring method, so I will. I'll leave this up for a minute. Sorry about my last mistake. I don't want to erase this, but I'm going to have 12 boards, so what can I erase? I'm going to erase that guy. Delete, clear all drawings. So now, if I want to use the factoring method, I get 6x squared plus x equals 12. Subtract 12 from both sides. 6x squared plus x minus 12 equals 0. This is a good practice of the AC method. So first I multiply 6 times a negative 12, which gives me a negative 72. I need it to equal a positive 1 because that's what b is. So that means 9 times a negative 8. 9 minus 8 is 1. 9 times 8 is negative 72. So now I rewrite this as 6x squared plus 9x minus 8x minus 12 equals 0. I do my grouping. I put a plus sign in here to remind myself I am not multiplying, I am adding. First thing I have in common in the first one is a 3x, which leaves me a 2x plus 3. My next one would be a negative 4, which leaves me a 2x plus 3. Remember, these two things have to be identical, which they are. Don't forget to write the equals 0, because it does equal 0. Then I finish grouping, and I get 3x minus 4 times 2x plus 3, all equals 0. So then I take my first guy and I set him equal to 0, so 3x minus 4 equals 0. Add 4, add 4. 3x equals 4, divide by 3, divide by 3, x equals 4/3. Take my next guy. 2x plus 3 equals 0. Subtract 3. So then I get 2x equals a negative 3, divide by 2, divide by 2, and then x equals a negative 3 halves. So obviously, if you're okay with factoring is definitely a much easier way than doing completing the square. The problem is when things are not factorable, you have to do completing the square. Good news, if you don't like completing the square, quadratic formula always works as well. So that's what we'll do next class. Next class, we'll do some quadratic formula and then some graphing stuff. And then we'll probably move into a little bit of any questions or stuff on Monday.